Okay, welcome students. Get ready to solve ATP paper. This is paper 6 by the way of 0625 IGCSE March 26 paper. It is a very recent paper with TPS. In this paper, we are having 1 hour time to solve this, and this is paper 6-2. So it is a 40 marks paper. Let's solve this. Here we have question number 1. In this question, dear students, a student determines the density of a glass ball. So when we are saying density of a glass ball, so we must remember that density is equal to mass divided by volume. And here they are saying glass ball. One thing more come to in our mind, that is volume of glass ball. Volume of glass ball. It is a spherical shape, so it will be 4 by 3 pi r cube. Moving to A part, the student pours water into a measuring cylinder until it is approximately half full. Until it is approximately half full. So, moving forward, the student places the measuring cylinder of water on a top and balance. And one thing more that we have to know here, that top and balance is used to measure mass. The student records the combined mass M1 of the measuring cylinder and water. This is combined mass M1, mass of measuring cylinder and water, and it comes out 125.6. So now in part 1 of part A, they are saying describe one technique. So dear students, whenever they say technique, you have to consider some experimental thing, experimental based reason, experimental reason or technique you can say, for using top and balance to measure the mass of measuring cylinder and water to ensure accurate reading. So dear students, for accurate reading, what technique must be followed so that for using a top and balance, your reading of mass comes out very much best one, accurate. So you are interested to find the exact, or you can say better reading of mass using top and balance. So what I would be suggesting here, that in short, top and balance is placed on a level surface. Level surface. This is very important. If level surface is not there, it means your top and balance is not going to be balanced. Top and balance should be balanced, should be level in a proper way. For example, it should be not like this. Oh my goodness. The top and balance should not be like this. It is very bad. This is inclined. It should be smooth like this. Like this. Means where exactly leveled horizontal surface should be there. Not little bit slopy surface would be there like this, like this. It should not. It should be level. So this point we will be writing here. Other than this, if you are interested to add more, what you can do is wait for the reading to become constant. Wait for the reading to become constant. You know, when you are placing a measuring cylinder on this top and balance, this is a measuring cylinder, and you are pouring a water into this, reading of this is changing. Here we are having a reading, might be it is 100, then 100, 5, 107, like this, it is changing. So you have to wait before recording the value. So wait for the reading to become constant and then record it, then note it, and then record it. So I have written 2 points for you. One is here. 1 point you can write this one, and 1 is here. So it's up to you. They are asking one technique, so any one you can write. So you have to remember how to measure the mass using top and balance, and the reading should be accurate. So we have part 2. Figure 1.1 shows the water level in the measuring cylinder. Record the volume V1 of water in the measuring cylinder. So dear students, if I zoom this picture, you can see here we have 10 deviants between 90 and 100. So this thing is indicating that one deviant, one div is equal to 1 centimeter cube. So it means this is going to be the point. So this point will be representing to 91 centimeter cube. So be careful regarding making the values. So I will be writing 91.0 centimeter cube. Here it is already given. Moving to part 3. Describe 2 techniques that student uses when measuring the volume of water to ensure an accurate reading. So dear students, one thing I would add here, I was solving the paper of IGCSE, October, November 2025. In that paper 6.1, 6.2 and 6.3, even in my June, they are asking you so many questions regarding this. So you must remember the techniques here. So describe 2 techniques that student uses when measuring the volume of the water to ensure an accurate reading. So the very one basic should be that you have to read the lower meniscus. If you add the water in the measuring cylinder, you might observe there are 2 edges of the water you can see. Suppose this is measuring cylinder. I add the water in this. Suppose this is the water in this. So might be you observe that there is somehow like this, the surface is shown to you. So this is the upper meniscus, upper layer. And this is the lower. So we are interested to read the lower one. If you want to measure accurate reading, it is good to read the lower bottom meniscus. So I will be writing here that read lower, or you can say bottom meniscus. Sometimes students say read the lower level of the water. That is also correct. No issue. That is also correct. But it is good to write the technical word here. Then another can be that you have to read the reading at eye level. Read this value at eye level, so that parallax error should be avoided. So I will be writing here that record, or you can say read, it is better to write read the scale of measuring cylinder at eye level. Why? To avoid parallax error. So you can add this point. So moving to next part of this question number 1, the student places 4 glass balls into the water in the measuring cylinder. So what is happening here, my dear learners? If suppose this is the measuring cylinder, in this we have a water liquid. So what is happening? Student is adding 4 glass balls in this, ensuring no water splashes out. So this is also a learning for you, that whenever you have to add the ball, they can ask you that about which thing you have to be very careful. So you have to be very careful that no splashing should occur. So the student records the mass M2 of the measuring cylinder, water, and 4 glasses. So now this M2 is going to be mass of measuring cylinder, water, and 4 glass balls. So the mass is 132.8 grams. So in this question, you have to calculate the mass of 1 glass ball. One glass ball. So what we are going to do, this is total 132.8 minus the mass of measuring cylinder and the water. Measuring cylinder and the water, that is 125.6. You have to subtract this 125.6. So if I subtract it, so let's see what is the answer I am having. 132.8 minus 125.6. Okay, so I'm getting this 7.2 gram. So this is for glass ball. We have to consider M. So 7.2 divided by 4, because 4 balls are there, we are interested to find the one glass ball mass. So I divide this with 4, so I am getting 1.8 gram. So hope so this is clear. Moving to next part. The student records the volume 2 of the water and 4 glass balls. This is the volume of water and 4 glass balls. Calculate the volume of one glass ball. So how you will be finding the volume of one? So 94. If you remember, previously we have calculated the volume of water, that is 91. So we will be getting the volume of balls. I say volume of object. So what we can do, volume of irregular object, you can say, or volume of object is equal to volume of water and object together minus volume of water. I am basically doing this. And this is known as displacement method. You are done with your paper 2, theory paper, displacement method. In that you have covered this, you have revised this. So what I am getting 3 centimeter cube. So this is going to be for 4 balls, 4 glass balls. So for 1, it will be 3 divided by 4. So what the answer you get if I divide this 3 divided by, so it is going to be 0.75 centimeter cube. So we are done with this. Moving to third part of this question. As you know, this question is regarding density of a glass ball. So here they are saying calculate the density of glass ball. So we are going to calculate the density of glass ball.
So use your values from 1bi and 1b, the previous parts, use the equation. So I'm having mass, that is, I think I have calculated here. Let me see at 1.8. 1.8 divided by 0.75. So if I calculate this, 1.8 divided by 0.75. So dear students, it's come out 2.4. This is in gram, this is in centimeter cube. Units are important, so be careful here. So it will be gram per centimeter cube. So we are done with this. So C part, the last part of this question, 10 marks question it is. Suggest 2 improvements that will help a student to determine more accurate value for the volume of a glass ball. So here the suggestion is use more glass balls and divide by the number of balls. It will be giving you more good value of volume. This is a very technical point, by the way. Use a measuring cylinder with small scale division so you can even measure more accurately the volume. So I'm talking for the volume, my dear students. I explained this, what I said. Suppose this is a measuring cylinder. Here I am having a measuring cylinder. So this is filled with liquid, and I add the balls here. Previously we have added 4 balls. I add more balls. So what happens? Level will rise more. So big difference will come. Suppose this value comes out 110 centimeter cube. If I am having the scale greater than 100 centimeter cube, and volume is 91 centimeters cube, so I will be taking the difference. So this will give me a better reading. Use more number of balls. So even the mass will also be improved. Mass. mass which you are measuring from the top balance, that will also be improved. So this is one way. The other way I told you, the second improvement which you can add here, use measuring cylinder with smaller scales. Smaller scales mean that you can even measure in millimeter cubes. So you are getting more accuracy value, accurate value. You are measuring very, very minute value as well. So I will be writing here that add more balls in measuring cylinder and then divide by number of balls. Instead of this, I write here complete word number of balls to find mass, or you can say volume. Then you can use measuring cylinder. Use measuring cylinder having small scale, so that small scale, or you can say small scale deviance, so more better results can be measured, more better results can be recorded. So we are done with this. Hope so this is clear. Moving to next question, question number 2. A student investigate the behavior of a spring. This is related to deformation, I think so. Refer to figure 2.1. If you see here, spring is attached and no load is there. This is 100 centimeter scale, by the way, you can see here. Okay, the very first part, describe two techniques the student uses when measuring the length of the spring to ensure an accurate reading. Okay, so one thing is the reading should be measured at eye level. This is very important, at eye level. Instead of this, one more way I can go here, that use set squares to record accurately the edge values of the spring. Edge values of the spring. Edge values of the spring means what I can say here. If I show you this picture very closely, I draw set square here. Set square in this way that, for example, I will be using a very sharp pencil here. Like this, I have to measure this, so I will be using here a set square like this. In the same way, use set square on the other side as well, in this way. So this will help you to measure these values, my dear students. These values will be measured accurately. So this can also be the one technique. One, I have told you that measure from eye level, so that parallax error should be avoided, and one is this. So one more is possible. Why not you bring this scale, this vertical scale, closer to the spring, so that you can have an idea. If I bring the scale more closer to the spring, you will be able to measure the length more accurately. This is too much close, little bit far from the spring, but it should be closer to this, like somehow this way, in this way. So this is going to give you the more best value here. So apart from this, one more thing that you have to ensure that either the scale is vertical or not. If scale is not vertical, then there is a problem. It will not give you the good result. Values are going to be wrong. So these are the three techniques I have told you. So we are going to write here. So one, I will be writing here that keep the ruler closer to the spring. Keep the ruler closer to the spring and also ensure that it is vertical. This is not tilted one, vertical. This is one point. Second, my dear students, it can be that measure at eye level. At eye level, the reading should be measured. Reading should be measured. So that parallax error should be avoided. So this point is similar to the previous question as well. So here we are on part 2. Use figure 2.2. Record the initial length of the spring with no load. Load is not attached. Do not include the loops. Loops are these ones. These are the loops. We are not interested in this. At the ends of the spring, even loops are these ones. These are turns, basically turns, but these are no doubt the loops, but we basically say the turns of the spring. But anyhow, you can here they are saying at the ends of the spring, these are basically the loops, or we say hooks as well. In your measurement, show clearly on figure 2.2 how you made your measurement. So dear students, this is very important. So I will be using set square, or I can use here meter rule as well. So you can see how I am going to record the value. So the value is going to be, keep your pencil as sharp as possible. So this value is going to be this one. One value I'm going to record from here. And the other value which I'm going to record is this one. So you can make a set square here. It will be a great representation then. Use a set square. Draw a set square here. In this way. In this way. Even you can draw a small triangle inside this as well. Draw a small triangle inside this as well. Yeah, it is a representation of set square. So what is this value? You have to be very careful because some values are hidden. So this is 36.1, 0.2, 0.3. This is 36.5. So here I am having 36.4. And this value is going to be 38.5. These are in centimeter. These are in centimeter. So what will be the measurement of this length? So they are asking in millimeters. So what I will be doing, 38.5 minus 36.4. So let me calculate this value. 38.5 minus 36.4. Okay, dear students, it comes out 2.1 centimeter. So we are interested to calculate in millimeter. So this will be 21 millimeter. So you know, when we are going to move from centimeter to millimeter, some teachers say that multiply with 10. Actually, what is happening behind this, I tell my students the story of this. 2.1 centi is basically 10 power minus 2. So we need here 10 power minus 3. So what we do, we multiply with 10 and divide with 10. So this 10 is going to be multiplied with this. So this becomes 21. So this is 10 power minus 2, which is this one. And this power, this is having 1. When it go to the numerator, it becomes 10 power minus 1. So according to indices, when there is a multiplication and base is same, you add the power. So it becomes 21 times 10 raised to power minus 3. So this becomes millimeter. So this comes out by practice. So I suggest my students to do as much as possible. This is a very technical thing, why we say that multiply with 10 and 100 and 1000 like this. So anyhow, moving to part B. The student suspends load 1 Newton from the spring. Oh, great. Now the load is going to be attached. Record new length of the table in table 2.1. So readings are there. So you can see in millimeter. So we have to find the extension. They are saying calculate the extension x of the spring using this equation. So my dear students, we know L naught we have calculated, that is 21.0 millimeter, or you can say 21 millimeter. Now we have to record the value of x. So this will be 42 minus 21. So this comes out 21 millimeter. No need to write the units here because already it is written in the heading. So even no need to do this working here. You can do here somewhere if you are interested. So then 61 minus 21, it will be 40. Kindly cross check this values. Might be I'm wrong, but I also checked this. Then you can use even calculator. 82 minus 21. This will be 61. No need to write the units again. I repeat. Then 107 minus 21. It is going to be 86. Then 125 minus 21. It is going to be 104. So we are done with this. I think table is here, so graph question will be very much possible. It is going to be given to you. Okay, anyhow, so plot a graph, load in Newton in y-axis, x on x-axis, start the axis from the origin, draw best fit line. Okay, so let's do this. X is going to be 21 to 104. Anyhow, let me bring this table near to the graph so it would be easy for me. I copy this and I paste it here so it will be easy for me to see the values. Okay, so here I am on x-axis. I want to keep x, yeah, x. So my dear students, always remember you have to label the graph first. So we are going to take here x in millimeter. That is very important to mention. So it is starting from 21 to 104. This is the range. So what I'm going to do is I take 10 boxes of x-axis, 1, 2, 3, 4, 5, 6. So 6 boxes are there. So what I do, I take values till, let me check the range, 1, 2 divided by 6 or 110. If I take, it will be not appropriate. 109, 6, no. 106 divided by 9. 104 if I take, that is not giving us exact value. 108 divided by 6. Okay, I take a 108 maximum value and if I divide it with 6, so my one jump of 10 small boxes will be equal to 18. So this is indicating that one small box will be equal to 1.8. So here I am having 18, then it is going to be 36, then it is going to be 54, then dear students it is going to be 72, then it is going to be 90, and then it is going to be 108. And here we have origin 0, even 0 is here. So I also label now the vertical axis, that is going to be load in newtons. So I'm having 5 values. So here what I do, let me check how many vertical points are there possible. 1, 2, 3, 4, 5. Okay, I take 5 only, 5 values. So it is going to be 1, 2, 3, 4, 5. So let's take the values. If you see when there is 1 Newton load, so extension is 21. So it will be where 18. So the value will be somewhere. We have to take 21. So 21 times 1.8. So it is going to be, so we have to take 11.6 boxes. So this will be somewhere here. I plot across here. So in this way you are going to take, you have to be very, very careful here. So now on 2 Newton load, the value is 40. So it will be 40. So how many boxes small we have to cover? 40 divided by 1.8. So it will be 22.2. So it comes out in between. 22.2 is somewhere here. We will be taking the point. Then, my dear students, 3 Newton load, 61 is the value. 61 divided by one small box. So you will be getting the idea how many boxes we have to move. 61 divided by 1.8, it is 33.88. So approximately you can say 34 boxes. So it is going to be 10, 20, 30, and we will be somewhere here. Let me use the scale so that I must know where I should plot the point. Yeah, 33.4. Okay, it will be somewhere here, like this. This is going to be point here. So this will be the point. Then when load is 4 newtons, so 86 you have to plot. So 86 divided by 1.8, 47.7. So we are going to move 10, 20, 30, 40. It will be somewhere here 40. Then here we will be having 45, 46, 47. Somewhere here. Here is going to be the point. So here is going to be the point. Then 104. 104 is going to be somewhere 57.7, or you can say 3, 4. That is, scale is so small, spread is not too much. 3, 4, 5, 6, 7, somewhere here. So the point is going to be somewhere here. Okay, I plot the cross. So these are the points. So we are done almost. So we have to draw the best fit. So your points should be balanced. So use a sharp pencil. Yeah, I think this is going to be much, much better. So it is good if you draw this on the page, then it will be more appropriate. Excellent graph I am getting here. This is the best suitable fit line, best fit line. Okay, we are done with this. I think again I recheck, scale is done, axis is labeled as well, all is okay. Okay, moving to next part. Then we have, it was by the way 4-mark question. State and explain if your lines show L and X are directly proportional. Yes, obviously, because you can say it is a straight line graph, and it is starting from 0 as well. So I would say for state, yes, it is directly proportional. It is directly proportional because it is a straight line. As load is increasing, extension is also increasing. Extension is also increasing. If your reason will be correct, then you will be getting the marks, otherwise you will not be getting the marks. So by the way, we are done with this. A big question, 10 and 11 marks question. We are done with 50% more than by the paper. We are done with 21 marks paper. Okay, we are on question number 3. A student investigates circuits containing different combination of resistors. So A part is saying figure 3.1 shows circuit 1. Circuit 1 is here, figure 3.1. So it is a ammeter is here, resistor is here, voltmeter is here. Okay. Switches and battery is connected. Okay, circuit contains one resistor of resistance X ohm. So its resistance is X. The student closes the switch and measures potential difference and current. Record in table 3.1 the voltmeter and ammeter readings shown in figure 3.2 for the circuit 1. Okay, most of the time what happens, student skips to read the scale. So my dear students, I would be suggesting you to read the scales very carefully. One thing, and also read these statements very carefully. It is very important. I know by doing so much practice, you know that what is written here, that they are demanding to note down the values, measure the values, record the values, but you have to read. After that, you must remember what the scale is. So my dear student, here we have 10 divisions. 10 division and gap is of 1. So 1 division, one small division, I would say, one small division is equal to 0.1 here. And on this side, if I come, one small division is equal to, how you can find, I tell you, 0.2. This is the gap. So number of divisions, how much? 10. So this will be 0.02. So anyhow, we have to record the value. So it is coming out 2.4, and this one is 0.26. Is it so? No. I'm wrong. It is 0.32. Okay, so moving forward, we have to record the values in the table. So 2.4 units are already there. No need to write it. 0.32 is the current. So we have to record the resistance as well. Okay, might be later on they will say, I'm doing only the thing what they have said, but I know what is going on with this. Figure 3.3 shows circuit 2. So here what is happening, you can see 4 identical resistors, each of resistance X ohm is connected. This is X, this is X, this is X, this is X. And by the way, they are connected in series in this way. They are connected in series in this way. But see the box, this box. This is indicating that they are connected in parallel. So you know how to find the total resistance for the parallel. So this will become 2x. This will become 2 1 over 2x, 1 over r total. So this will be 2x is going to be the LCM. So 2. So 1 over r total. So when you find this r total, it also becomes x. So anyhow, okay, circuit 2 contains 4 identical resistors of each X ohm, they also say, but this X is going to be different by the way. The student closes the switch and measures the potential difference and current. So you have to record the values, again the same thing. So here I'm having 2.3. Here it is 0.3. Okay, I record these values here. It is important. 2.3 and 0.3 is 0. Okay, move to next. What they say. Calculate the and record. Calculate and record in table 3.1. So it is important. You have to record the values, the resistance of each circuit. Give your answers to 2 significant. So this is very important. No flexibility is there. You have to give the answer in 2 significance. So use your readings from table 3.1 and the equation shown. So I was telling you that I know what we have to do here. So anyhow, you have to do the working here. So R is equal to, I think, 2.3 value we have measured, and then 0.30. And R is equal to 2.4 divided by 0.32. So dear students, we will be finding the value here of resistance. 2.4 divided by 0.32. It comes out 7.5 ohms. Then 2.3 divided by 0.30. So this becomes 7.66. So what I do, I round this to 7.7 ohms. So you have to note, record these values in the table. That is 7.7. Too significant. That's why I have rounded one thing. I tell you here, too significant. 7.5, too significant. So these are the two values. We are done with this. One mark question, but anyhow. Okay, theory suggests that resistance of circuit 1 and circuit 2 are the same. So whenever this type of question comes, you must remember they are going to ask you about limit of experimental accuracy. Limit of experimental accuracy. That will be less than equal to 10%. So they are saying state whether the results support this suggestion. Justify your statement by reference to the values from your results. So how you will be taking the justification or reference of that values? So I know one value is 7.7, other value is 7.5. You will be taking the change. So I write here change in resistance divided by the resistance value. So two values are here, and we are having ammeter and voltmeter readings. This is very technical point, but I tell you here, ammeter and voltmeter readings are there. So dear students, when this type of question is given, you are measuring the readings. So this R value, remember, this R value will be the R average. One thing. This is, by the way, very technically we are looking into this. But for the ease, because we are having so many students, and all the students are not going to be of same level. I'm not going to degrade anyone. I'm going to make the ease for my students, for my learners. So if you get difficulty in taking the average, so on the other way around, I say my students that take the change, then divide it with R. This is not, by the way, technically right, but it will give you the right answer. This is going to give you correct, but this is not for all the students. We have to carry everyone anyhow. So what we are going to do, we are going to divide it with 7.7 plus 7.5 divided by 2. So anyhow, it becomes 0.2 divided by, if I find the average, it will be 7.6. So we are going to multiply it with 100 as well. I miss here 100. So anyhow, I write on the other side here, it will be 100 as well. So dear students, when you are going to multiply it with 100, you will be getting the percentage. So let me calculate this. So 0.2 multiplied with 100 divided by 7.6. So this is going to be 2.6%. So other way around, the thing I was saying you, 0.2 divided by 7.7 are greater value. You do this, so even then you will be, if multiplying with 100, you will be getting the same answer. But we are not supposed to take this average every time. This is the main thing. Suppose you are measuring the reading from the meter rule, and no need to go with that, because its least value, its Persian is something else. By the way, if you are retaking the values of time using stopwatch, then it is important because you take so many values. So anyhow, we will be writing that it is within the 10%, less than equal to 10% accuracy. So yes, results of resistance, by the way, results show that resistance of both circuits are same. Resistance of both circuits are the same. Reason is both values lie within the limit of experimental accuracy. Already I told you what is limit of accuracy, limit of experimental accuracy. That is within 10%. So anyhow, this was a very good question. Anyhow, moving to part 5, figure 3.5 shows circuit 3. So many resistance. So all are in series, and they are parallel to each other. So circuit contains 9 identical resistance, each of resistance X. Everyone is having 3 X resistors, so this becomes 3X. So anyhow, I'm going to go for any other thing. Prediction is there, so a range of values will be there, but suitable values. Predict the resistance of this combination of resistors. So for prediction, go back, you see initially we get 7.5, then 7.7, when the circuit 2 was used. In circuit 2, the 2 resistors are in series and 2 branches were there parallel. Anyhow, here 3 resistors are in series and 3 branches are there. So obviously you can see little changes occurring. So obviously the value will also be changed, but it is going to be increased one. And this thing is very important, which you have to consider why it is increased, because of the comparison we are looking into this. So anyhow, and by the way, in branches, they are connected in series, resistance is increasing. After that, when you are going to solve it parallelly, obviously resistance in parallel decreases, but anyhow, it is not going to decrease that much. So prediction is might be becomes 8, might be it becomes 7.9, might be it become 8.1. So what I would be writing here, I would be suggesting 8.0. So moving to part B, another student performs the same experiment but uses digital meter. That is very good. So many problems are going to be handled. So state one advantage of using digital meter. So one important point is that you will be having no variation, no fluctuation will be there, no problem for the parallax error will occur, and it is easier to read as well. So I would be writing that no parallax error will be included, and it is easy to read. And it is easy to reading. So here is the digital meter displays when it is connected in a circuit. So this much reading, 290 milliampere. To record the value of the current shown in ampere. So 290 milli is 10 power minus 3. It is a prefix. You must remember about the prefixes. So you can write this as well, but it is better to write here 0.29. So 290 divided by 1000. Why 1000? Because when you take this 10 raised to power 3 in the denominator, it becomes positive. Suggest 2 reasons why the switch is opened after readings taken. So very common question this is, to save the power supply to battery so that charges are not going to be destroyed, battery will not discharge, and to prevent the components to become overheated. So I will be writing to prevent components to become overheated. This is one. Second, I told you to save battery from being discharged unnecessary. So we are done with this question. This is also a big question, by the way. So here we have investigation, a planning question, a design question, very easy, and a scoring question, by the way, of the ATP. So we have to read the statements very carefully. A student investigates the rate of cooling of water. Rate of cooling of water. So rate means here time, is also included, and cooling of hot water means somehow they are measuring about variation in heat, variation in heat. In a container which has a lid, okay, it is covered with the lid as well, so that heat is not going to be lost in the surrounding too quickly. Plan an experiment which enables the student to investigate the effect of different starting temperatures on the rate of cooling. Okay, starting temperatures will be different. How the effect of different starting temperature means, initially you take the hot water at 98 degrees Celsius, 80 degrees Celsius, you take at 60 degrees Celsius, you take at 40 degrees Celsius. So how the temperature, starting temperature, if you are taking, how it affects in the cooling rate. So the apparatus available includes a beaker, measuring cylinder, supply of hot water, a lid. In your plan, state any additional apparatus required. Okay, before jumping into this, I write here a point, one that is brainstorm. Brainstorm is, in this, I will be getting the idea that what we have to do in this. What we have to do in this. So, dear students, one thing, we are going to perform an experiment by taking water at different temperatures. Different temperatures. I have told you what the temperature will be. So what other thing you will be doing here, you will be recording the temperature and time. So you know time is going to be independent here, and temperature is going to be dependent. You have to be very careful about this point. Which point is going to be dependent and which one is going to be dependent. That is, by the way, very important here. So anyhow, moving to next, you have to repeat it. Repeat in sense that you will be repeating this experiment for different temperatures. Repeat it for different initial temperatures. Different initial temperatures. So you can either brainstorm like this, or the other way around. If I do so, there is a possibility. What I do, you can design a beaker here. You can draw a rough diagram and cover it with a lid. But in that lid, there should be a hole that a thermometer can be inserted into that. So it is filled with hot water. What is happening? One time you do by taking the temperature 90 degrees Celsius, then again do the experiment with different temperature. But before that, you note down the temperature here, and then see every minute that how the temperature is decreasing. If you are taking a high temperature water, will the value going to be decreased quickly or not? So anyhow, this was the brainstorming of the question, which will help you to write the points for here. Explain briefly. This will help you here. Explain briefly how to do the investigation. So, dear students, list additional apparatus, state any additional apparatus required. So I will be writing here additional apparatus required. Stopwatch to measure the time, and I think thermometer is not given. You can use that thermometer. So these are the 2 points. Now we have to explain briefly how you will perform the experiment. So I would be saying, take beaker and pour hot water, and then cover it with lid, and also insert thermometer in it to note down in it to note down the variation of temperature at every minute. This thing is done. Then what will be this? By the way, this is very easy question. Then repeat the procedure. By taking different initial temperature of the hot water. And record the values of temperature at every minute. By the way, I have said repeat the procedure. Record the value of temperature at every minute. So, but keep the volume constant here. This thing is very important. So might be they are asking you the key variable. Yeah, they are asking. So once you are done, place a tick here. So state the key variables to be kept constant. Key variables are the physical quantities which we have to keep the constant. These are not constant values. There is a difference between constant values like G value is 9.8. Acceleration of free fall is also 9.81 or 9.8, you can say. Value of, you can say, this value of diameter of Milky Way, that is a constant value. Speed of light, that's a constant value. But variables to be constant is something else. So, key variables to be constant are volume of water. This can be a constant value. And what else you can take here? Initial temperature we are supposed to change. Same beaker you can use, lid, same room temperature, that is very important, surrounding and time interval. So like this you can write here. So at least two, please mention two at least. So same volume of water, same time interval, because we are measuring the time as well according to the temperature, same time interval, and one more I write here, same room temperature, same surrounding temperature. Okay, so what else is here? Draw the table or tables with column headings, even with units, to show how to display your reading. You are not required to enter any value. Students never enter any value. So we draw a table here. And one thing is that is time. Then one thing that is temperature, one temperature, second temperature. At least 3 is important. 4 or 5 can also be, but 3 are fine. So then we have rate of cooling as well, which you are measuring according to the time. So here we will be having the headings. So this is going to be time in seconds. Theta 1 I am writing for the temperature. Theta 2 for another temperature. Theta 3 for another temperature. Theta 4 for another one. Theta 5 I am taking 5 values. And here it will be rate of cooling. And this will be in rate of cooling. So degree Celsius per second, rate of cooling. So be careful regarding this as well. So we are done with this table. Now we have to write the conclusion. Conclusion is very important. In conclusion, you have to see how to use your readings. We are not having any readings, so be very generic here. So you know that temperature decreases at every minute, but we have to show that how we are going to compare the values. So I would be saying compare value of temperature with every time interval. With each minute, you can say time interval, and then compare, and then analyze. It's better compare. We are already doing comparison, and then analyze how cooling rate is affected. Cooling rate is affected. By the way, it is affected. So, dear students, we are done with this paper. If you have any question regarding this paper, you can do let me know. And this is going to be a great help for the students who are having their exam on 19th May 2026. So, hope so this will be a great help for you. So, by that and day, take care, stay blessed. Hope so this is going to be a great help for you.